Hello everyone. In the today's session, now I am going to discuss the examples on Milnes method here. Okay, the first example now we can consider. Okay, here now in the today's class, now we can discuss the examples on the Milnes method. Okay, the first one now we can specify in terms of given. Okay, the given dy by dx is equal to the x square plus y by 2. Now we can estimate y of 1.4. The initial data is given y of 1, 2 here, y of 1.1, 2.2156. Okay, y of the 1.2 here is 2.4649. Now the next one y of 1.3, 2.7514 here. Okay, first we construct the table is in the form of okay, now x value, y. Okay, first we can consider x, the next one y here. Okay, now the next one f function x comma y is nothing but the given x square plus y by 2. Okay, now we can denote in terms of x naught. Okay, x naught be the initial data 1 here, y naught 2. Now x1 1.1, y1 here. Now the 2.2156. Now x2 here 1.2 here, y2 here 2.4649. Now the next one x3 here 1.3, y3 now we can specify in terms of okay the given the 2.7514, right. Okay, now the next estimation in such a way that now we can specify in terms of okay, now at the particular point x4 1.4, y4 to find out. The first one f naught, now we can specify in terms of okay the f of x naught comma y naught. Okay, f of x naught comma y naught means here now here replace x naught square plus y naught by 2 here. Now after the simplification now we get here f naught. Okay, after the simplification now while substitution now we get okay here 2. Now we can f1 here 2.3178. Now the 2.6724. Now next one f3. Okay, f3 here f of x3 comma y3, right. Okay, f of x3 comma y3 here is now replace here x3 square plus y3 by 2. Okay, after the simplification now we get 3.0657. Now the question, we have to estimate the y4 value at the particular point x4 using the Milnes method here. Okay, now next observation. Okay, next one now we can specify in terms of using Milnes predictor formula. Okay, using the Milnes predictor formula now we can specify y4p is equal to the y naught plus 4h by 3. Now the 2f1 plus okay now we can specify in terms of minus f2 plus 2 f3 here. Okay, first we can find out. Okay, here now the y4p here is okay y4p here y naught. Okay, y naught initial data 2 plus okay, and also here h value now the common difference for the x now we can specify in terms of the 0.1. Now we can consider in terms of Okay, the 4 into the S, 0.1 denominator 3, right? Okay, the 2 F1, okay, S 2 into the F1, okay, F1 available 2.3178 minus F2 available, okay, now we can denote in the particular form, okay, F2 here as, okay, now 2.6724 plus 2 into the F3 here, okay, F3 here 3.0657, right. Okay, now using calculator, now I can simplify y4p here. Okay, now after the simplification, now we get y4p here 3.0793. Okay, now the next one, now we can denote, right? Next, the Milnes character formula, now we can consider in terms of, okay, Milnes character formula, now we can specify in terms of, okay, now the y4c is equal to the as y2 plus h by 3 as, now the f2 here plus 4f3 plus f4p we have to consider. Okay, now before going to the expansion formula, first we have to find out separately f4p here. f4p is nothing but f of x4 y4p. Okay, f4p is equal to the s, f of x4 is nothing but 1.4, right? y4p previously simplified 3.0793. Now substitute in the function, after the simplification we get 3.4996 here. Okay, now we can specify in terms of 3.4996 here. Okay, now substitute here y4c, right, y2, okay, y2 value means here, now from the table, now we can consider in terms of y2 here 2.4649 plus h value, okay, h value here 0.1, now denominator 3, okay, f2 value means here 2.6724, right, plus 4 into the f3 here 3.0657 plus f4 already simplified. Okay, now simplified data, now we can consider in terms of as the corresponding here f4p here 3.4996. Now using calculator, now we can find out y4c. Okay, the character value, now we can consider in terms of the particularly here 3.0794. Now we can specify here. Okay, finally we can conclude y of 1.4 is equal to the 3.0794 here. Now once again the repetition of the second example. Now with the help of Milnes method, now we can simplify. Initially data are given, right? Given, first we can construct the table form. Okay, the table form in such a way that first now h value 0.1. Okay, by the observation of the x data, now we can consider in terms of h value 0.1. Okay, next one here x0 here 1 given, x1 1.1, x2 1.2, x3 1.3. Now the question y of 1.4, now x4 here 1.4. Okay, y4 values to find out. Okay, now y4 value to find out here is we can specify in terms of function f of x comma y, x square plus y by 2, f0, f of x0 comma y0 2, f1, f of x1 comma y1 2.3175 after the simplification, f2 here f of x2 comma y2 2.6724. Okay, likewise f3, now after the simplification with the help of x3 y3 3.0657 here. Okay, now we have the Milnes predictor formula. Okay, with the help of the predictor formula, now we have y4p is equal to the y0 plus 4h by 3 2f1 minus f2 plus 2f3 here. Okay, right. Now the y4p here, substitute the data here, y0 2, 4, right, h value 0.1, denominator 3, 2, right, f1 substitute, f2 substitute, f3 substitute, okay, 2 available constant. Now with the help of calculator, after the simplification, now we get y4p is equal to the 3.0793 here. Now, since accuracy is too less in the predictor formula, that's why here Milnes consider another alternative formula like the Milnes corrector formula. Okay, now the y4c is nothing but y2 plus h by 3 f2 plus 4f3 plus f4p here. Now what about here next one, y4c here y2 2.4649, right. Now the next one, now h value now we can consider in terms of 0.1, right. Okay, denominator 3 here s. Okay, f2 now we can replace 4 into the f3 here we can consider f4p. Okay, f4p is nothing but f of x4 y4p. Okay, previously simplified y4p, already available x4. Using that, now f4p now we can simplify. Okay, 3.49965 here. Now here substitute here. Now after the simplification we get y4c is equal to the 3.0794. Okay, that's why here now we can consider y of 1.4 now is nothing but 3.0794. Okay, one of the important observation in such a way that, okay, with the help of Milnes method, now we can estimate the corresponding the y4 value at the particular x4 1.4. Okay, now that will be the important observations here. Okay, next example. Okay, now the next example, second example 3 here. Okay, now what about here, given dy by dx x square plus y square with the initial data given, with the help of the corresponding by Milnes method, find y of 0.4. Okay, now the answer. First construct the table. Okay, now by the observation h value here 0.1. Okay, the table data now we can specify in terms of x value, y, f function. Okay, f function is nothing but x square plus y square. Now the corresponding here, now we can assign f of x comma y, right, given x naught 0, y naught 1. Okay, here x naught 0, y naught here 1 here. Next one, now x1 here 0.1, y1 here 1.1113. Now next one, now we can specify in terms of x2 here 0.2, y2 here 1.2507. Now x3 here 0.3, y3 here, right, 1.4260. Now at the point x4, 0.4, now we have to estimate y4 value to find out. Okay, with the help of the f0, f1, f2, f3 here. Okay, yes, the first one f0 initializing. Okay, f of x0 comma y0. Okay, f of x0 comma y0 means here, now the already the data available, now we can specify in terms of 0 square plus 1 square is nothing but 1. Now we can denote in terms of. Now the f1 here, okay, f1 means here, apply in the function f of x1 comma y1, substitute. Okay, x1 0.1 available, y1 1.1113 available, that's why here substitute here. Now we get, right, After the substitution, now simplification, now we get 1.2450. Next, x2, y2 here. Okay, now is nothing but f2, f of x2 comma y2, right? Okay, substitute in the function. Okay, here x2 here 0.2 square plus 1.2507 square. Now after the simplification, now we get 1.6043. Okay, now the next one is now f3 here, f of x3 y3 here. Okay, x3 0.3 square plus, okay, function available, y3 here 1.4260 square. Now after the simplification, now we get the 2.1235. Okay, now the next observation. Okay, the next one now we can specify in terms of by Milnes predictor formula. Okay, by Milnes predictor formula means here now we can specify in terms of y4p is equal to the y0 plus 4h by 3, right, 2f1 minus f2 plus 2f3. Now we can denote in terms of here. Okay, now if y4p is equal to the y0, now refer the table as y0 here 1 plus 4 into the h value. Okay, h value means here the check the x data, the common differences here, the we can consider in terms of the 0.1 by 3, right. Now the 2 f1, okay, now check the table, f1 is nothing but into 1 minus, now f2 here 1 point, okay, f1 available here, okay, just replace the f1 value, okay, f1 available 1.2450 minus f2 here 1.6043 plus 2 into the, right, f3, okay, f3 means here 2.1235. Next observation. Okay, the next one now we can consider in terms of using calculator. Now we can simplify. Okay, after the simplifications, now we get y4p 1.6844. Now we can specify in terms of. Okay, once we get the predictor value, we required for the next formula. Okay, now what about here? The Milnes character formula. Okay, the Milnes character formula means here as y4c is equal to the y2 plus h by 3, right. Now the next one, now we can specify in terms of f2 plus 4 f3 plus f4 p. Now we can denote in terms of here. Okay, now what about the next one? As here we required f4p. f4p is nothing but f of x4 y4p. Now the f4p is nothing but apply the values of x4 along with the y4p in the function as. Now x4 is nothing but 0.4 square plus y4p 1.6844 square. Okay, now f4p is nothing but after the simplification we get 2.9972. Now substitute in the character formula. y4c is equal to the, now we can specify in terms of y2 here. Okay, y2 means here 1.2507 plus h value 0.1 by 3. Now f2 here 1.6043 plus 4 into the right, f3 value substitute 2.1235, right. Now the next one plus f4p, already the previous value now simplified, now you can substitute here 2.9972. Okay, after the simplification we get y4c is equal to the s 1.68. Now we can consider in terms of 72, 1.6872. 2 here. Okay, next observation. Okay, next we can specify in the particular form here. Okay, here the corrector formula one time applied. Okay, better accurate result. Now the one more time now we can specify in terms of here F4C to find out. Okay, F4C means here f of x4 comma y4c substitute. Okay, f4 of c is nothing but now substitute in the function. Now we get 3.0067. Now the same formula expansion here, just replace 3.0067 here, y4 c1 we get. Okay, finally we get after the simplification 1.6875 here. Okay, therefore the finally we can conclude that y of 0.4 is equal to the 1.6875. Okay, we can estimate y4 value at the particular point of x4, that's why here y of 0.4 1.6875 here. Okay, once again the example, the explanation. Now in such a way that the given example, first construct the table. Okay, especially for the Milnes method, table now we can specify in terms of the properly now we can denote in terms of the corresponding x0 value, x1, x2, x3, x4. Now the next one now we can specify in terms of corresponding y0, y1, y2, y3, y4 here. Okay, f0, f1, f2, f3, the function assigned in place of f0 here, x0, y0, first simplify. Now f1 find out, f2 find out, f3 find out. Now the next one, we have the Milnes predictor formula. Okay, Milnes predictor formula y4p, y0, 4h by 3, 2f1 minus f2 plus 2f3 here. Okay, now y4p here is y0 replace, 4 h value replace, denominator 3, 2 f1 from the table, refer the table, now substitute, f2 refer the table, substitute, now 2f into the f3 value, substitute. Using calculator now we can simplify, we get y4p is nothing but 1.6844 here. Now the next one, apply Milnes corrector formula. Okay, Milnes corrector formula here, y4c here, y2 plus h by 3, right, f2 plus 4, f3 plus f4, p here, right, y4c is equal to the y2 1.2507, h 0.1 by 3, f2 here 1.6043, 4 into the f3 here 2.1235 plus, okay, f4p, okay, already we simplified, f4p is nothing but f of x4 comma y4p, substitute, now simplify, we get 2.9972, here replace. With the help of calculator now you can simplify. Next, one more step, we can apply the corrector formula another one time. Now in such a way that f4c is nothing but f of x4 y4c. Here already predictor value available, here corrector value replace. We get f4c here 3.0067. The same expansion, only the replace. Here instead of 2.9972 here, the corrected f4c value 3.0067. Now we get y4c1 1.6875 here. Okay, finally we can conclude now y of 0.4 is nothing but 1.6875 here. Okay, that's why here we can estimate y4 value at the particular point of x4. Next example, given 5xy dash plus y square minus 2 is equal to the 0. Now with the table data is given. Now by Milnes method find y of 4.5 here. Okay, now the first one, h value here 0.1. Now the table data now we can consider in terms of. Okay, the table data important. X, now the y value, f, okay, the function f of x comma y, right. Okay, the function y dash can be represented in terms of directly. Now what about here is, okay, y dash now we can specify in terms of the particularly here the 2 minus y square denominator 5x. Okay, right, x naught from the table, x naught here 4, y naught, okay, 1, Now x1 4.1, y1 here is 1.0049, right. Now x2 here 4.2, y2 here is 1.0097, right. Now x3 here 4.3, y3 here the given data is 1.0143. Now we can specify in terms of, right. One more data is given. Okay, the another data is given. x4 4.4, y4, right, 1.0187. Now the question, now x5 4.5, y5 to find out. Okay, now the next we can specify in terms of S. Okay, now what about your S? Now we can consider in terms of F naught. Okay, F naught here, F of x naught, y naught you can replace. Okay, after the simplification now we get 0.05. F1, F of x1, y1. Okay, x1, y1 here. Now after the simplification now we get the 0.0483. Now F2 here is f of x2 comma y2 here. Okay, now substitute, now we can simplify, we get 0.0467. Now next one f3 here, f of x3 comma y3, right. Okay, f of x3 comma y3 means here now the after substitution simplification 0.05045 2. Next x4, f of x4 comma y4, right. Now the f4 value here 0.04, now we can specify in terms of 37. Okay, next one now we can represent in terms of the corresponding here. Okay, right. We have by Milnes predictor formula. Okay, Milnes predictor formula now we can consider in terms of S. Now we have y4p is equal to the y0 plus 4h by 3, right, 2f1 minus f2 plus 2f3 here. But here we required the y5. Next step length now we can specify y4p is equal to the y1 plus 4h by 3, right, 2f2 minus f3 now plus 2f4 now we can specify. Okay, the previous examples directly now we can estimate y4p here, but here y5p, the next value now we can specify, that's why here rewrite the formula in terms of another alternative form here. Okay, y5p here, substitute y1 1.0049 plus 4 into the h value 0.1, denominator 3, right, 2 into the f2 here. Okay, now we can consider in terms of 2 into the f2 here 0.0467 minus, now f3 here 0.0452. Now next one plus 2 into the f4. Okay, now f4 here into 0.0437. Now substitute. Okay, y5p here. Okay, with the help of calculator. Now after the simplification, now we get 1.023. Next, the Milnes corrector formula. Okay, Milnes corrector formula means here y4c is equal to the y2 plus h by 3, right. Now we can specify in terms of f2 plus 4f3 plus f4p here. Now rewrite the formula in terms of y5c here. Okay, y3 plus h by 3, right. Now here changes, next one value f3, 4f4 plus f5p here. Now f5p, now f of x5 y5p. Now substitute here, simplify, now we get now the corresponding 0.0424. Okay, now here substitution we get y5c is equal to the, now we can represent in terms of 1.023 here. Okay, now what about here? Finally, now we can conclude, therefore y of 4.5 1.023. Okay, one of the important observation, now we can estimate instead of at the particular point of x4, here at the particular point of x5, y5 value, that will be the important thing here. Okay, now we can specify in terms of, now we can represent the initially data given, first f0, f1, f2, f3, f4, now we can find out. Okay, Milnes predictor formula available, we can rewrite another alternative form. Now we can first find out y5 of p 1.023 here. Now the next one, Milnes corrector formula first we consider, but we required y5 of c, that's why I rewrite the formula. Instead of y2 here y3 taken, h by 3 right, instead of f2 here f3, instead of f3 here f4, now f4p here f5p, now we can specify. f5p we can find out later, now we can estimate y5c here 1.023 here. Okay, finally we can conclude y of 4.5 is equal to the 1.023 here. Okay. Now, these are all the examples on the Milnes method here. Okay, thank you for watching the video.